In this notebook, we will review Python basics. Here's what we'll cover. First, we'll start by installing Python and setting up your environment. Then, we'll learn about Python syntax and indentation, which is critical for writing correct code. After that, we'll explore variables and data types, followed by how to write comments and docstrings to make your code readable. Next, we'll move on to basic operators and expressions. This includes arithmetic, comparison, and logical operators, as well as assignment operators. Then, we'll dive into string operations and how to perform typecasting to convert between data types. In the control flow section, you'll learn how to use if, elif, and else statements to make decisions in code. We'll continue with while loops and for loops to repeat actions and see how to manage loop behavior using break, continue, and pass. After that, we'll focus on data structures. We'll cover strings, lists, tuples, sets, and dictionaries, and learn when to use each. Finally, we'll explore functions and modules. You'll learn how to define and call functions, work with arguments and return values, understand variable scope, and use star args and double star qugs. We'll also learn how to import modules, including both standard libraries and custom Python files. By the end of this section, you'll be comfortable writing clear, reusable, and well-structured Python code. Let's begin. Installing Python and setting up the environment. Let's start by installing Python. Go to python.org and download the latest stable version. Python 3 is strongly recommended for all modern development. When installing on Windows, make sure to check the box that says Add Python to Path. This will allow you to use Python from the command line. For Mac OS and Linux, Python may already be installed, but it's often outdated, so it's best to install the latest version manually. Once installed, open a terminal or command prompt and type python-version to confirm the installation. If you see a version number, you're good to go. Setting up the environment. Next, let's set up the environment for writing and running Python code. I recommend using Visual Studio Code, or VS Code. It's lightweight, free, and has great support for Python. After installing VS Code, install the Python extension from the Extensions panel. You'll also need to use the terminal, either from VS Code or separately to run Python scripts. Optionally, install Git for version control, especially if you're planning to work on team projects or use platforms like GitHub. Finally, create a dedicated folder for your Python projects. This will be your working directory. Python syntax and indentation. One of the most unique features of Python is its syntax and indentation rules. Unlike many other programming languages that use braces or keywords to define code blocks, Python uses indentation, that is, whitespace at the beginning of a line. Indentation is not optional, it's part of the syntax. By default, most developers use 4 spaces per indentation level. It's critical to be consistent. Mixing tabs and spaces or using irregular indentation will cause indentation errors. Always format your code cleanly, and your editor, like VS Code, can help with this automatically. Indentation is used in many common structures like if statements, loops, functions, and classes. For example, take this simple function, def_greetName, and print hello name. The line inside the function is indented, so Python knows it belongs to that function. If we have nested blocks, like a loop inside a function, we just add another level of indentation. This clean structure is one of the reasons Python code is easy to read and understand. Variables and data types. Variables in Python are containers used to store data, like numbers, text, or even more complex objects. You don't need to declare the type of a variable. Python uses dynamic typing, which means the type is assigned automatically based on the value. You create a variable using the equals sign, like x equals 5, This makes x an integer. Python supports several built-in data types. The most common are int for whole numbers, float for decimal numbers, str for strings or text, and bool for true or false values. You can use the type function to check what type a variable is holding. Python variables are flexible. You can reassign them to different values or even different types. For example, x equals 5 sets x as an integer, but then x equals text turns it into a string. This is another example of Python's dynamic typing. You can also get input from users using the input function. For example, name equals input, enter your name. Keep in mind that input always returns a string, so if you need a number, use type conversion like int or float. This helps keep your data in the correct form for calculations and logic. Comments and docstrings. Comments and documentation are important for writing clear code. A comment is a line in the code that is ignored by Python. It is used to explain what the code is doing. Comments help both you and other developers understand the logic behind your code. Docstrings are used to describe the purpose of a function, class, or module. They are placed at the beginning of the function or class and written using triple quotation marks. Using comments and docstrings makes your code easier to read, maintain, and debug. Basic operators and expressions. Arithmetic and comparison operators. Let's begin with arithmetic and comparison operators in Python. Arithmetic operators are used for basic math. You can add, subtract, multiply, or divide numbers. Python also supports more advanced operations like exponentiation, floor division, and finding the remainder. Next, comparison operators are used to compare two values. For example, you can check if two numbers are equal, not equal, greater than, or less than. These comparisons return either true or false, which is useful for making decisions in your code. Logical operators. Now let's talk about logical operators. These are used to combine multiple conditions or reverse their results. The AND operator returns true only if both conditions are true. The OR operator returns true if at least one condition is true. The NOT operator flips the result. True becomes false, and false becomes true. Logical operators are often used with comparison operators to build more complex conditions. This becomes very useful in decision-making code, such as if statements and loops. String operations. In Python, a string is a sequence of characters surrounded by single or double quotes. You can join or concatenate two strings using the plus operator. To repeat a string multiple times, use the multiplication operator. You can also access individual characters using indexing starting from 0. Use slicing to get a part of the string by specifying a start and end index. Remember, strings in Python are immutable. Python provides many built-in methods to work with strings. You can convert a string to lowercase or uppercase. You can remove spaces from the beginning and end using the strip method. Replace parts of a string or split it into a list of words using replace and split. You can also check if a word or character exists inside a string using the keyword in. For combining variables and text, Python supports several ways to format strings. The most modern and readable way is to use f-strings. You can also use the format method to insert values into placeholders inside a string. Typecasting. Typecasting means converting a value from one data type to another. For example, you might want to turn a string into a number or a number into a string. Python provides built-in functions for this. The int function converts a value to an integer. The float function converts it to a decimal number. The star function turns it into a string, and the bool function converts it to a true or false value. Typecasting is especially useful when working with user input, since input is always read as a string. Control flow. If, elif, else. The if, elif, and else statements are used to control the flow of your program based on conditions. The if statement checks a condition, and if it is true, the indented code block runs. If the first condition is false, the elif block allows you to check more conditions. If none of the if or elif conditions are true, the else block runs as a final fallback. Make sure to use a colon at the end of each condition line and indent the code that belongs to it. This structure helps your program make decisions and respond differently in different situations. While loop. The while loop is used to repeat a block of code as long as a certain condition remains true. Before each repetition, Python checks the condition. If it's true, the loop runs again. If the condition becomes false, the loop stops. You often use a counter variable to control how many times the loop should run. Be careful. If the condition never becomes false, the loop will run forever. You can also use break to stop the loop early, or continue to skip the rest of the current cycle and move to the next one. For loop. The for loop in Python is used to repeat actions for every item in a sequence. That sequence could be a list, a string, or numbers from the range function. For example, you can loop over each character in a string or over each number in a list. Python automatically assigns each item to a loop variable. You can also use break to exit the loop early or continue to skip to the next item. The for loop is one of the most common ways to process data in Python. Break, continue, pass. Python gives you extra control inside loops using break, continue, and pass. The break statement stops the loop completely, even if the condition is still true. The continue statement skips the current loop cycle and goes directly to the next one. The pass statement does nothing. It is often used as a placeholder when writing code that you want to complete later. These statements help you write cleaner and more flexible loops. Data structures. Strings. Strings in Python are used to store text. You define a string using either single or double quotes. Strings are immutable, meaning you can't change them once they're created. You can combine strings using the plus operator and repeat them with the star operator. Use the len function to get the number of characters in a string. You can access individual characters in a string using indexing. Python starts counting at 0, so s bracket 0 is the first character. Negative numbers count from the end, so s minus 1 is the last character. Slicing lets you take parts of a string. The syntax is string, then open bracket, start colon, end, and close bracket. The character at the end index is not included. You can leave out the start or end to slice from the beginning or to the end. Lists. A list is a built-in data structure used to store multiple values in a single variable. You define a list using square brackets and separate items with commas. Lists can hold different types, like numbers and strings together. You can access items by index. Index 0 gives the first item, and -1 gives the last. Unlike strings, lists are mutable. That means you can change their contents. Lists are very flexible. You can change an item by assigning a new value to a specific index. To add items, use append to add to the end, or insert to add at a specific position. To remove items, use remove, pop, or the del statement. You can also slice lists using start and end indexes, just like with strings. Finally, use the in keyword to check if an item exists in the list. Tuple. A tuple is a built-in data structure that stores an ordered collection of items. Tuples are similar to lists, but unlike lists, they are immutable. That means once a tuple is created, you cannot change, add, or remove its elements. Tuples are defined using parentheses and can contain different types of data. You can access tuple items using indexes, just like with lists. Since they cannot be modified, tuples are faster and more secure when you want to protect your data from changes. Sets. Sets in Python are collections that store unique, unordered items. You define a set using curly braces with comma-separated values. Any duplicates are automatically removed. Sets do not store items in any specific order, so you cannot access them by index. Sets are very useful for operations like union, intersection, and difference. They're also great for quickly checking whether an item is present. Use sets when you want to ensure that all values are unique and order doesn't matter. Dictionaries. A dictionary in Python stores data as key-value pairs. You define a dictionary using curly braces, with each pair written as key, value. Dictionary keys must be unique and of an immutable type, like a string or number. To access a value, use square brackets and provide the key. If the key doesn't exist, this will raise an error. To avoid errors, you can use the get method. It returns none or a default value if the key is missing. You can add a new item to a dictionary by assigning a value to a new key. If the key already exists, its value will be updated. To remove items, you can use the del statement or the pop method. Dictionaries also support helpful methods to get all keys, all values, or key-value pairs. You can loop through a dictionary using the items method, which gives you both the key and the value. If the key is missing. Data structure comparison. This table compares the four main data structures in Python. Lists are ordered and mutable and allow duplicates. They're great for general-purpose collections. Tuples are also ordered, but they are immutable. Use them when your data should not change. Sets are unordered and only store unique items. They're best for fast membership checks and removing duplicates. Dictionaries store key-value pairs, allowing fast access using unique keys. They are ideal for structured or labeled data. Choose your data structure based on your specific use case and requirements. Functions and modules. Defining and calling functions. Functions allow you to group reusable code into named blocks. To define a function, use the def keyword followed by a function name, parentheses, and a colon. Inside the function, you write the code to run when it is called. You can pass information into a function using parameters. To run a function, call it using its name followed by parentheses. If you want the function to return a result, use the return keyword. Arguments and return values. Arguments are the values you pass into a function when calling it. These values are used by the function to perform its task. A function can accept one or more arguments. To send the result back from a function, use the return statement. The return value can be of any type, like a number, string, or even a list. You can store the return value in a variable or use it directly in other expressions. Variable scope. Variable scope refers to where in your code a variable can be accessed. A variable created inside a function is called a local variable. It only exists while the function is running. A variable created outside all functions is called a global variable. It can be accessed from anywhere in the file. If you want to change a global variable from inside a function, you must use the global keyword. Understanding scope helps you avoid unexpected behavior and naming conflicts in your code. star args, and double star quags. In Python, you can make your functions more flexible using star args and double star quags. The star args parameter collects any extra positional arguments passed into the function. These arguments are stored as a tuple. The double star quags parameter collects extra keyword arguments and stores them in a dictionary. This is especially useful when you don't know in advance how many arguments your function might receive. Remember, in a function definition, normal parameters come first. Importing modules, standard library, and custom. Modules allow you to organize and reuse code in Python. To import a module, use the import keyword followed by the module name. Python comes with a powerful standard library that includes modules like math, random, and datetime. You can also import specific items using from module import item. Custom modules are just your own Python files with a .py extension. You can reuse your own code by importing one file into another. Modules help keep your code clean, organized, and maintainable.
Thanks for watching.